By this point in the course, we've talked about quite a lot of advanced topics, including traits. There's one topic missing at the moment, and we haven't really touched it yet until this point, and that is asynchronous programming in Rust. So let's try to focus on that in this part of the video. Now, Rust supports asynchronous programming with async and await, as you're probably familiar with that in programming languages such as JavaScript, Swift, or even Dart. However, Rust takes a little bit of a different approach to asynchronous programming in that it provides you with the basics of asynchronous programming. However, it will require something called a runtime from third-party libraries in order to be able to deliver the full experience to you. And we will have a look at one or two of those runtimes in this part of the video when we talk about asynchronous programming, so that you just get used to not being completely reliant on Rust's basic implementation of async and await. So let's go ahead and write an asynchronous function in here, and you can see we call it getName, and what it does, it just returns a string to us without waiting. So we prefix our function declaration with async, with the keyword async, and we say fn, and we call it getName. And this function, what it does, it just returns a string, and we just say John to string. Okay. So that's a basic function implementation for us. So if you want to turn a function to an asynchronous function, you prefix it with the async keyword. Now, you can go ahead and try to call this function in your main function, and you'll see that it is quite easy to just call it. You just write the name of the function. However, you will get a compile time error. So let's just go ahead and say let's name is getName, as you can see in here. And if we then try to print this, let's go ahead. We say print ln, hello. There we go. So now we have this error in here saying that this is a future and that we can't basically just print it to the console. And this is one of the basics of asynchronous programming. You can't just call an async function without awaiting on it. Okay. So what we're going to do in order to work with futures and in order to be able to wait on futures and await on them with the await keyword, we're going to use a runtime called futures. Now, there is a website for if you want to, for instance, add third-party packages to your application. And I think we've actually looked at that before, and it's called crates.io. So what you need to do is to go to crates.io and search for futures. And once you find futures, you can see the version number in here. So let me just bring up the title. Excuse me. So you'll see here the last release was 6 months ago, and it says that in order to install it, you just have to add the following line to your Cargo.toml file. So let's just copy this and let's bring it to our Cargo.toml file. I'm going to say Command P in Mac and Control P on Windows on Linux. So let's say Cargo.toml. There we go. It's right here. And inside dependencies, we're just going to paste this line in here. I'm going to bring up the terminal, and as soon as I save this file, you'll see that it will start basically importing futures into our package, into our binary crate. So it says waiting for file lock on package cache. So what I'm going to do is going to stop the execution of the program. I'm going to save this file in here, and then let it do its work, and then I'm going to do a cargo watch, waiting for file lock on package cache. Okay, that's fine, I think. So we're going to just let it do its work. We're just going to have keep an eye on it. So let's make sure that it is going to install futures for us. At the moment, it doesn't seem so good. I think it's like gone into some sort of a recursive, maybe a lock. So what I'm going to do is I'm just going to close this Visual Studio Code instance and bring it back up. So let's just do that. Okay, after doing that, I can see that here we had some compilation happening. So it turns out that I had two copies of my project open at the same time, and there was some sort of a recursive lock perhaps, so on the cache file. So now that I did that, I basically closed Visual Studio Code and open it again. Then I can see that the compilation for futures actually did happen. Now we're still getting our error. That's fine. I mean, the error is still present in here. We can actually try to comment these two lines so that at least our application builds successfully. So that's that. Now, what we're going to do is to go ahead and do something called awaiting on an asynchronous function. So let me just close these in here and bring this here. And let's just say let name is now equal to block on is a function that is brought from futures inside our application. So cannot find function block on, that's fine, because we're going to have to use futures in our application. Okay, so let's go ahead and import this. So we're going to say import futures executor block on. So this is use futures executor block on. Okay, and then you get access to a function called block on. Now, if you have a look at what happened in here after you did block on this function, then the result of block on is actually the value being returned from the function. So it's kind of like doing a wait on that function. Okay, and the result will then be printed to the console saying hello John. So this is one of the things that you can then use from the futures cargo package, basically. Okay, now you can also use the await syntax on asynchronous functions, and you don't have to use a block on. So in order to do that, we're going to use another runtime called Tokio, and Tokio is going to be a little bit more advanced package, I would say, with a lot more functionality than just futures. And we'll actually have a look at some examples of using Tokio later in this course as well. So for now, let's go to Cargo in here, crates.io, sorry. And then we have search for Tokio, and you can see the latest version for that is 1.21 at the time of recording this video. Excuse me. So let's go ahead and include Tokio in our Cargo.toml file. So you can see it was released 11 days ago, and this version may be different from the point of recording this video until when you're watching it. So if you see this version being a little bit different, don't worry about it. You can still use the latest version if you want to, or use the version that I'm including in this, or the version that I'm talking about at the bottom of the screen, as you can see. So what we're going to do, we're going to go ahead and use some features of the Tokio library that aren't included by default into Tokio. So what we need to do is to make sure that futures flag is set to full. So let's copy this line from here, from dependencies, and bring it to our Cargo.toml file. So cargo, and then let's just paste this here. Let's monitor the terminal as well, and just to ensure that Tokio will be included without problem in our application. And see, it's going really fast actually. So it just did all the compilation work and it's ready to go. So now we have access to Tokio as well. Okay, now let's go ahead and import two of the functions that we need from Tokio. So let's include a path for that. We say use, and we say Tokio, and then we say time, and we need both sleep and duration. Okay, so these are the two functions that we need from there. So you can see sleep is a function, and also duration is actually a structure. Okay, so let's import those using their paths. Now, what we're going to do is going to go and write the first asynchronous function header. And so let's just remove this get name, and let's remove these, and let's go and create two functions in here. They're both going to be asynchronous. So we're going to say async and fn call API1, okay, and let's just assume that this returns a string. And inside this function, what we're going to do is to go ahead and sleep for a certain amount of time. And that just means whichever thread is awaiting on this function is going to need to sleep for a given amount of time, which is going to be for 1 second. So we're going to say call the sleep function, and we're going to say the duration is going to be 1 second. And you can see then using Tokio, we can use this new functionality here, which is called await. So this is a little bit different from what you may be used to. For instance, in Dart, you would just take an async function and just await on it like this. But in Rust, you're going to have to append await to the end of your future, because otherwise, if you say let foo, you can see that actually this is a sleep, which is a future basically, which we can await on. So let's remove this and put await in here. So you can see now we have mismatch as expected. Okay, so let's just return John, for instance, to string from here. Oops, like that, so the error goes away as well. So what we're going to do, actually return this, change this John to the value of string of 1. So we're sure that call API1 is returning the value of 1. And then we're going to go ahead and create a similar function, and we're going to call it call API2. And in this call API2, we're going to do exactly the same thing as call API1. Instead, we're going to change the word 1 to 2. So let's copy this from here and paste it over here, okay? And change this to the value of 2. Great stuff. I'm going to remove this debug or the terminal from the bottom of the screen as well. Okay, now that you've done this, what we're going to do is, it's going to be equal to, the function itself needs to also be equal to, okay? Now, after doing that, what we also need to do is to turn our main function into an async function. And there's a header that you can place right before your main function declaration, and that is called tokio main. And by doing that, what you're doing is that you're turning your application into an asynchronous Tokio application. Okay, so let's go ahead and do that. As you can see at the bottom of the screen, Tokio, and we're going to say main. So this is a Tokio main function. Okay. And what we need to do then is to turn this function into an async function, as you can see. All right, so now our main function is able to become an asynchronous function. All right, so I'm going to bring up the header for that as well. So just prefix async before your main function. Now you have an asynchronous main function. Then what we're going to do is to go ahead and call the first API without using block on. So we're going to use the await syntax as you've seen before. Okay, so let's say one is call API one, and then we're going to await on it, and then let's just print ln. We're going to say one. Okay, so if I bring up the terminal, you can see the value of 1 being printed to the screen. So that's the result of calling the first API. And we're going to do the same thing with API2. So I'm going to copy these and then going to say call API2. Okay, let's change this as well to 2 and print 2 to the screen. So let's go to the terminal, and you can see then 1 and 2 being printed to the screen. But what was important is that API1 at the moment is being called, and it blocks the current thread, and then API2 will be called, which blocks the current thread as well. So you have this serialness into calling these APIs. So by doing an await in here, your program is literally waiting for call API1 function to be done, return its result, and come to the println statement before it moves on to calling the second API. And that's the little delay that you can see. Let's remove this features from here. And that's the little delay that you could see in here. Look, wait, 1, wait, and then 2. So this is because of the await and their blocking. Now, async functions don't have to use the async fn, as you've seen here, and they can actually return a future. So this is a little bit, this is like a mishmash of Swift and Dart. In Dart, if you were creating an asynchronous function, actually, wait a minute, this is pretty much similar to Dart. So in Dart, if you're creating an asynchronous function, your function can, for instance, return a future, or your function itself can be marked as async, meaning it can do some asynchronous work. So it is pretty much similar to what we're doing in our function in Rust in here. So the main function is marked as async because it is calling asynchronous functions. However, the functions themselves that are doing something asynchronous are marked with async. And this is something in Dart you would pretty much never do. You would return a future of string. And the same thing is actually true in Rust. So let's go ahead and import the future trait. We're gonna go ahead in here and say use futures and future in here. So this is just a trait, as you can see in here, which is available in the futures library. Then we're going to go ahead and change our function signatures so that they return a future. So let's remove this async in here, and let's just say that this returns an implementation of future. Its its output is going to be a string, as you can see in here. Okay, so that's that one. And then what we're going to do is inside this function itself, we're going to go ahead and use something called an async block, as you can see in here. Okay, let me bring up the title for it. So in this async block, then after you've turned your function into returning a future, you're going to do your work like this. Okay, so just like that. So now your function is returning a future, and it's not marked as async itself, except in itself it has an async block. And we're going to talk more about that actually. Let's turn the second function as well to the same thing. So let's copy this and place it in here. Okay, and then remove async from function 2 as well. Create an async block in here and put these two lines of code in there. And now you can see we've turned those functions into futures, but the call site remains the same. So this is the beauty of using futures and, for instance, Tokio together, in that they play very nicely. And so Tokio main function is using futures trait that comes from the futures library. Okay, so the call site stays the same, no changes to that. Now, we need to also talk about the lifetime of variables that are inside async blocks. So you can see in here, what we did is that async block in itself is creating a variable that is stored in the heap, and this value is being returned then from this function. Now, usually this is okay when you create a variable inside an async block. It lives on for as long as that async block lives on. So that's usually not a problem. But the problem usually arises when you try to do something outside this async block, like do some code in here as well, and then use a variable from outside the async block in the async block. That's where you have to be a little bit careful about lifetimes, okay? Now, just to be sure, just to ensure that your variables are living as long as the async block lives on, it is usually a good idea. It's actually the best idea to ensure that your variables are actually created inside the async block so that they live on for as long as the async block lives on. It's very rare you have to do something from outside the async block and then import it into async. But if that situation does arise, you just need to have a good think about, okay, is this variable really going to live on as long as the async block lives on? Okay. Now, asynchronous functions can actually move variables. So the async block will take a variable from outside the async block, and it has the ability, if you mark the async block as a moving async block, as you'll see an example soon, then that async block has the ability to move a variable from outside the block into the block. So let's have a look. At an example. So what we're going to do is we're going to have a function here called get async name. Okay, so I'm going to copy this function signature from here, and let's go place it here and say get async name, and it just returns a future with an output of string. Now we're going to create a local variable in here called a name, I believe, John Doe. So let's say name is John Doe to string. Okay, so this is a string being created outside an async block. Now, if you want to be able to then return this name from outside an async block, so we're going to create an async block and return it. Okay, so if you want to be able to safely do this, you need to ensure that the lifetime of this name is as long as the lifetime of the function that owns the async block. And that is why you need to create a moving async block, and that is marked with async move in here. Okay, so we have, let's say in here, actually, did we call it John Doe? I believe so. So let's just say John, actually. Let's rename this to John. And then what we're going to do is just going to do a format. And in this format, we're going to say hello, something like that. Hello, something Doe. And then we're going to put the name, and then we're going to return it as to string. Okay. Does it not return string to string like this? And format is like this. I believe format actually did return a string already, and this is fine. Actually, I believe this returns a string. So yeah, so we don't have to turn this into a string. That's what I mean. So you can see in here we created a name, and then we're using a moving async block in order to move this variable from outside the block into the block, and then do some formatting with it, and then return that string to the caller. Okay, so asynchronous programming is actually is a big topic in Rust. We've just touched the tip of the iceberg in here. We looked at Tokio, we looked at features, we looked at how to create asynchronous functions, use block on. We had a look at turning our functions into pure futures with a specific output, for instance, and we looked at how we can await on futures as well. So we looked at async blocks and async move blocks in order to move a variable from outside the async block into it. So it is the tip of the iceberg, and we can't really go too much into async programming without having a look at proper examples. So what I've done is I've prepared 2 examples, which we're going to have a look at in right after this section of the video, which do use asynchronous programming and futures library and Tokio. So hope you enjoyed this part of the video, and I'll see you in the next part.